So quickly, I'm just writing this, what we're gonna call Elm ID. Well, yeah, I don't know what to call it. But it's basically the equivalent of GHC ID, and then this will be $1, $2, something like that. Okay, and then what we're gonna do is move this into bin element. So, okay, so the point of this is basically just that if I run elmid source photogroove and then elm.js, it will basically create a watcher that just checks to see if I've made changes to the file. So if I write touch source this, you'll see that I just compile the module because it receives some notification. So now all I have to do is write to that file. I automatically get this updated, and then I can automatically just go refresh my page and then use my app. Okay, so that's the idea of this. And again, this app right now from chapter 3 basically allows us to change these icon sizes. So, and then click on them, and we have this sort of view over here, and then we can also like select a random one. So that'll just select a random one. All right, so that's kind of cool. I presume that if I like change this, those things stay selected. Not surprisingly, that's all it does. It's not very interesting yet, but this is like our equivalent to GHC ID. So I'm just gonna call it Elm ID because I don't know what else to call it. There's no watch command for Elm, so you'd have to use Reactor, but Reactor doesn't work for us because it won't have all this CSS. So there's some CSS behind the scenes making this all work. So I don't particularly enjoy that yet, but that's how it is. Okay, so chapter 4 is all about. So let's remove chapter 3 each. That, because that's really all we need now. And yeah, let's put a readme in here. Chapter 4. So I think this one's going to be all about JSON encoding and decoding. So yeah, let's just look at this here. I'm going to delete this because it's probably no longer necessary for us. If I remember correctly, we don't even use array. Oh, we do. Okay. This is kind of weird, actually, that this even works. This should still compile, right? Yep. What's this complaining about? Oh, okay. It doesn't like that this is a... What's up, Jabby? Your CSS stream has given me a headache. I actually still have a headache from that. No joke. Yeah, it really messes my eyes like that. I have like focus problems. So when you have that thing streaming across the screen, it's really hard for me to focus on the text behind it. So yeah, it's like just it's a problem with my eyes. All right. I tried my best to look away, but then also it was like kind of mesmerizing and cool at the same time. So it's like a double-edged sword, if you will. All right. Anyway, we'll get moving here. So I think this is all about basically decoders and encoders for JSON. What's up, Fireball? How goes it, sir? Okay, so fine is okay. Did you see? Have you used channel points yet? And I'm doing well. Luckily, no work, but I'm kind of fighting a headache right now, so we'll see how long I last today. So at the bottom now we have these channel points, and you can do things like just unlock emotes for watching the stream, and also you can do funny things like put Santa hats on operators. We'll make this a reindeer. Or we can actually, oh, that's even better. Look at that. We can write flip bind. So kind of fun stuff like this you can do now. Here, I'll show you another example. So we'll turn apply into a reindeer. Sure, this one. You can do all kinds of weird stuff. Like, I don't know if you've seen that thinking face, but that's thinking about apply. It's not lol. I feel like I've seen that before, but I don't know where. Anyway, it's just silly. Kind of silly stuff you can do. There's like highlighting messages, which I should probably turn off because like that doesn't really make any sense. Like there's not enough of you that I need you to highlight messages. But like unlocking a random emote or choosing an emote to unlock, like that's totally fine. I want people to use those. All right, so the next thing we're doing in our application is wait. Oh wait, that's saying that we can do this thing. It's time to take PhotoGroove to the next level, the cloud level. We're going to have PhotoGroove start getting its information from our servers. Yeah, I mean, it's like, it's silly. It's just one of those things to try and keep you engaged while you're watching Twitch. So if you can put little Santa hats on emotes and stuff. Like for streamers like us, we don't have a lot of emotes. Like you can only have 3. So and like, you know, I don't get many tier 3 subs, so only one of them is actually active. So unless I use them in other channels, then they're not used very much. So the fact that you can unlock them and use them is kind of cool, I guess. Okay, so we're gonna read some photos from the cloud, from the internet, and we're gonna use you know, HTTP obviously and JSON to do client server communication. So we will figure that out here shortly. All right, so let me bring up our initial model. All right, so our initial model is basically this right now. So it's like hard-coded URLs that are images. And I assume what we're going to do is talk about like data that we can load up. So it says modeling loaded data. So there are 3 possible states. We're still loading the file. So that's like an initial state. So the file's not there yet. So we're going to create a new type for that because that's kind of what you do. Type alias status. Right. We want to do this. Loading. Loaded. I don't know why this is a list of photo. Oh, right. It is just type. Sorry. Some types are types. Record types are alias. Yeah, the alias does nothing in this case, actually, Danger. It's not supposed to be there. The only time you need an alias is when you have a record type. So that's, yeah. So this is a type alias for a record, and then a regular type is just a normal sum type. Does that make sense? That was just me being silly, basically. And I think we put 2 spaces in between everything because we like everything split very far apart and kind of spread out. I don't know why that is, but that's just what the you cannot. I don't think you can have a type record. I think it needs to be a type alias. So if we like try like make record hello world, yeah, see, so problem in custom type. I am partway through parsing a custom type, but da 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 da. So oh, right, maybe it does. Yeah, this works. Okay, so yeah, this is yeah, okay, interesting. This is more like a Haskell type. But I don't know what the difference is between type alias. Well, I guess we need to look that up, huh? Well, no. Okay. So a type alias is a type that has this, this type. Ugh. The type model is a record of list photo, string, and thumbnail size, right? So it's an alias for this record type. For the type down here, you're actually giving the constructor a name. So the type make record, has this constructor make record with the record inside, something like that. Yeah, that's a little strange, I guess. That I've really only made some types and then type aliases for records. Honestly, I don't think we've made anything else. Let's see. Yeah. So like this one doesn't really need to be a record type, but I just assumed we were going to put more data in there. And then here's just a regular sum type, and here's an alias, and regular sum type. Yeah. So anyway, it's kind of interesting. I didn't mess with that before, or look at that before. I suppose what we could do, like we could make this if we put this in the REPL, it might help make sense. But if you're still confused, I can drop into a REPL and we can poke around a little bit more. Yeah, this is like one of these really nice things in Elm and PureScript that Haskell doesn't have. Okay, where was I? Status. All right. So it says we'll begin in the loading state, and then we'll transition to either loaded or errored, depending on whether the server gave us some photos or an error. Oh, that's why, because we're going to make one request to a server for a bunch of photos. We're not going to make a bunch of different requests for a bunch of different photos. So, so this model, or this models a single HTTP request to a server for many files, many images, something like that. Okay, so now in our model, we also need to add this status, so we'll put it down here. So we're gonna have a status, and then now we kind of just start listening to compiler because it's gonna tell us where stuff is wrong. So we go over here, and initial model says it should be model, but it's not, right? Because the body of the record type is this, but it should have an additional field. So we need to go look in initial. Well, does it tell me where initial model is? It does, but it's a little high up here, so 53. So here we're gonna need to say status equals what do we call it? Loading. All right, where's the next error? I need to scroll down. That's it. That's actually all you need to change. We'll have to handle like actually loading the file, but you know, that's that. Okay. We did this. Oh, and then also, right, we don't need this photos anymore. And I suppose we won't have this selected URL thing either, which is kind of weird. I would have guessed that we still need the selected URL, but we'll come back to that, I suppose. Okay, so 53. $110. All right, so down here is where things start to get interesting. Wait, no, it wanted me to keep selected URL. That's, I kind of assumed so. I was a little confused for a second there why it would do that. No. Selected URL. No. Is there an empty string type? String. Well, yeah, but I was wondering if there's like another way to write it. I mean, this is obvious, but I don't think there's probably not a more straightforward way to write that. So anyway, so selected URL string. Okay. So we no longer have a photos field, which is like the next point. So this is what we got to deal with next, because we're going to go get our photos. Yeah, no menti, unfortunately. Okay, so we're going to case on model status. In our view. Okay, so that's going to go here. You asked them about it, and it's a very explicit design decision. That's interesting, actually. So, case model status of, and we'll put that closing parenthesis there because we're going to need it. So, loaded photos selected URL. Is that what loaded was? Oh yeah, I guess it was. So it would probably be a good idea to have selected URL as a separate type instead of a string, just so it's obvious. But anyway, that's besides the point. So view loaded photos selected URL model dot chosen size. So that's like our render the things function. If we are currently loading, just give me an empty list. And if we've errored, then we'll just say text okay, so this should type check if we delete that. except we haven't written this view loaded function yet, so we'll do that next probably. So view loaded is going to take a list of photo, string, thumbnail size, and return a list of HTML message. Okay, so we'll just put like a dummy implementation in there for now. Unfortunately, we don't have holes like we have in Haskell. That would be something really nice, I think. But this should compile, I think. Oh, we have some random integer selection, but we'll get back to that here in a second, I suppose. Okay. This is in the book in a different div. It's just called class content. So I think what's going to happen is likely we're going to deal with this chosen size later. So let's do class content. And I think the chosen size will end up being rendered down here. Or well, the HTML for that will be rendered down here, and we'll deal with that class that was up here later. So we'll just call this class content for now. Okay. Do. Wait. Oh, I see. We're actually going to remove like all of this. I get it. Sorry. I didn't understand it first. So we're going to basically take this whole thing and stick it down here. Although it went in the wrong place. Okay. So then we gotta fix this. So it would be chosen size. Chosen size. We obviously don't have this anymore. This is gotta go back up here. We'll let our formatter run and fix all this for us. Okay, and then down here we have selected URL. What's wrong with this? Oh, right. There needs to be something here. We need another list there. Like that. That should probably compile. Oh, not yet. We still need to deal with that random thing. Okay. So let me, oh wait, right, this isn't gonna work yet, so let's fix that. Yeah, nice. A brain with sunglasses on it, folks. So, yeah, we'll probably come back to this. Let's not worry about it. Yeah, like I can just make whatever I want now, which is nice. That one works out really good. I kind of like it. It's cutesy. Okay, so they're saying that this code right here, I'd like to format it, but I don't think the formatter will run. Oh, maybe it will. That's kind of nice that it runs here. Anyway, okay, so this code works fine, but it'd be shorter if we used the this operator. I don't know what it would be called. It's the reverse pipe operator or something. Yeah, triangle. Left triangle? I don't know. Anyway, flip triangle? Something like that. I don't like the ligatures. I know you're a big fan of the ligatures. I just don't like them very much. It's not a slice of pizza. Yeah, there we go. So it's left slice of pizza. Okay. So we could apparently, what they're saying is like we can just do this, I think. I'm actually surprised the formatter works. When GHC is broken like this, it does not let you format your code. So it's kind of nice, actually. It doesn't care that it's malformed, it just formats it. Okay. Nice, we did that. I didn't think about this, but I suppose this works. For anyone who's unfamiliar, this basically means take the output of this and pipe it to this as an input. It's kind of like a backwards pipe instead of a forwards pipe that you're familiar with in Bash or other languages that support pipes. Okay. So it says, next thing we got to do is resolve some data dependencies. So we got, wait, why doesn't model selected URL exist anymore? Oh, right. The selected URL exists inside of a different thing. I see. I see why this makes, or I see why I was confused before. So, this is no longer here. It is elsewhere. So we'll come back to that. Did I not scroll down? Okay, I did. It's here, basically. Okay, so got selected. All right, so here's the code that we need to fix. Um, all right, so basically here what we're doing is saying, look, if I have a loaded, I need to basically replace loaded with a new URL. If I have loading, just ignore it. If I have an error, just pass it through. Something like this. More robust implementation might return a maybe status so that update could fire off a command to record the error in a logging service. Okay. There's an aside about underscores as placeholders, but basically this just means ignore and ignore because we're just replacing these values with a new URL, or this one value with a new URL. And then we'll use this to deal with this. So like if we click a photo, what we now need to do is update our status with select URL get photo URL no. Select URL image with the status. And clicked photo, or sorry, got selected index will change status to select URL get photo URL deck. What's wrong with this? I'm guessing that get photo URL is wrong. Yeah, we need a list of photos. Let's see if that gets. Yeah, let's start by deleting our existing photo array definition along with get photo URL and random photo picker. Okay. Directly choosing a random photo. Da, 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 da. before we used a random number generator, like a random int and array.get. Apparently we can use this random uniform function. Okay. Okay, so I think these are both going away. And then we need to come down here. So if we click surprise, so pattern match out the photos and ignore the selected URL. Return a model where we generate got random photo random uniform first photo other photo. All right, this font's too big. That's is this okay font wise? The font's just way too big for the way that this gets formatted, I feel like. If you can't read this, just yell at me. I'm one of those people who is always annoyed when I can't read what's on people's screens, so if you need me to bump the screen size, just say so. All right, so what is this here? Still good? Wonderful. Okay, so we need to create, this is going to take an A and produce this message, I guess. What patterns have we not seen before? So this is just saying like pattern match out the first element, because you have to pass it that way to random uniform. Basically, random uniform can't take an empty list. That's kind of the idea. So you have to pass it a non-empty list. So in message, wherever message is, we're gonna have to get got random photo. All right, and then in our update function, we need to deal with that. Yeah, and this is no longer necessary because we don't have an index, right? We're just getting a random. Oh, and then command none. Oh, right. I gotta update this, get rid of that. So that warning right there was basically just saying you haven't checked everything. That's what it's saying. And I'm wondering if this is the same thing because it doesn't match for an empty list. So maybe we'll deal with that later. I'm not even sure. But, you know, this should basically, if we get an empty list, it should probably raise an error message or something. Yeah, missing patterns. Okay, yeah, and then this says basically just add loaded. Yep, and then that compiles. I'm not even sure what it's going to do. Literally nothing. There's nothing there yet because we haven't loaded any. We haven't loaded anything, so kind of funny. Okay. Says we have one more change to make, a stylistic one. We're going to express the first loaded branch as a pipeline of sequential operations by using tuple pair and the pizza operator. The right pizza operator, or the pipe. I'm just going to call it pipe. Right pipe, pass to the right. Left pipe, pass to the left. All right, so basically we're just cleaning up this. So instead of this, we can write the following. Random uniform, first photo, other photos. Pipe this to random.generate got random photo, and then pass this to tuple pair model. Okay, so random uniform, remember this is going to generate, I'm sorry, not, wrong way. Generate is gonna build us a model. So what we need to do is, I'm sorry, a message. So here's our message in these other cases. So what we're doing is just pairing up our model with our message. That's all we're doing. It's kind of cool, actually. This code looks a lot neater, I think. It's something that you have to pay attention to, though. Like, it's not trivial to see this the first time. But, like, now I see this, it's like, oh, yeah, I guess we can use tuple.pair to deal with this. So I could see it taking a little bit of time to get used to this style, but once you see it, it's pretty obvious. Okay. Yeah, so it says this is our refactor to get ready for loading. So what we're doing now, or what we're going to do next, is basically instead of having this literal black screen that does nothing, we're going to put some photos here, but we're going to get them from the internet. So that's kind of the next the next step. So it says fetching data from the server. So first things first, we need to install Elm Http. So to install stuff in Elm, you can just do Elm Http, like so. I assume we want all those things. I mean, it tells us we need those things, so we must need those things, right? Interestingly enough, it doesn't say anything about JSON here, but maybe that's just inside of HTTP. I don't know. All right, so it says the way that these functions work in Elm is a little different than you're used to, because Elm cannot have side effects, right? So you can't just like, I guess we'll see what this means here in a second. I'm not 100% sure what this is going to mean, but my guess is that calling HTTP endpoints will look a little different with Elm. Yeah, so here we go. So if we look up get in HTTP, you'll see it returns a message again. So it's like our random number generator. Mirachino, thank you so much for the follow. Really appreciate that. Are you a Elm programmer at all, or just kind of interested in learning about it? Web programming in general? I'm very friendly to questions, so feel free to ask questions. I may not be able to answer all of them, but I can try. Okay. Oh, right, we did the correct thing and we put it in the background. Okay. So it shows us how to generate some HTML, or I'm sorry, do an HTTP GET request. I kinda want to just keep moving until we get to the like the actual implementation. Here we go. There you go, man. See? Do your work. Good to go. So if you think about it this way: you work now, you can work less later, and you'll make more money doing it. And that's actually not true at all. You'll work harder, but you'll make more money, which is important. It's not everything, but it's helpful. Okay. Do. It depends. It doesn't really matter. Yeah. I mean, unless you're going to grad school, then your GPA does matter a little bit. But like, if you, it's more important that you have like internships and stuff. If you're, depends what you're doing. Yeah, like it may affect, like if you had, I don't think a 3.2 or 3.4 would be a problem, but if you had like, yeah, like a 2.2, it will limit which master's programs you can get into. That's for sure, because they will just use that as like a blanket statement to drop your application. Okay, I'm not entirely sure how this is going to work, so we're just going to play with it. But I believe that soon we should be able to make HTTP requests. So, well, I mean, that's probably less true. Like, If you had a relatively low GPA, but you somehow got a, usually this doesn't happen, but like you had a bunch of internships and like could prove that your GitHub was like full of great code, it would be a different story. Like some people just aren't good at college. I know a lot of people who didn't graduate college, and you know, their GitHubs will look a million times better than mine, so they will easily, yeah. It's like a, it's a company perspective. Like if you're an undergrad looking to code versus like going to grad school, like those are different. You know, they're looking for different things. Okay, so we're gonna import HTTP. And then we need to update our message because we're gonna need to deal with getting photos. So we're gonna get a result that can be, this is an either type, by the way. So it can be either an error or a string. And then we need to actually pattern match on this in our update function. So we'll do that. Got. I am not making a compiler. Someday I might want to, I'd like to make a compiler, but I don't think that's going to happen anytime soon. All right, so basically what we're doing right now is dealing with some HTTP. So so this is what's going to happen. We're going to basically go out and make an HTTP request for a bunch of photos, and either it's going to work, which is okay, or it's not going to work. That's kind of the idea. Oh, that's not. I'm kind of distracted. So this is like, yeah, why didn't I study computer science? I didn't realize that I wanted to do computer science until like I was way, you know, until I finished my PhD in chemistry. So it was like too late. I'm not going back, I don't think. Okay, so either like the response we get back from the server is going to be okay or error. So if we get an error, we just want to change our model, the status, to errored. Wait, why would we want that? What's an HTTP error? Is it not a string? I don't know what an HTTP error is. So yeah, server. So if that's the case, and we're just gonna say server error, there's no reason to keep either of these for now. We're just gonna make this compile and go from there. Yeah. I mean, like, you should definitely go to school for something you're interested in. So, you know, I'm still interested in chemistry. I just don't do it very often. Okay. Oh, and then this is gonna fail because we need command. So we don't want to return a message from this tuple. All right. So we got to deal with this piece next. So like if we make a URL request to a bunch of photos and we get the okay, we need to like parse these and update our status with the new list of photos. So that's kind of the idea. So I think that's what we deal with next. Okay, so here's the endpoint. Later, Jappy. So basically, we're gonna go make a GET request to this, and you'll see that it basically just gives us back a few photos, 4 of them to be exact, separated by commas. So I don't even know what this is. What did I just open? I legitimately have no idea. Oh, here we go. About. Oh, this is gedit. Okay. Never used that in my life. But there it is. We use gedit. So what we need to do is basically split that. So we're going to write a function down here called split CSV, because that's what we're going to do. Taking a string and a string, and we're going to make a list of string. What's the second string? Oh, duh, the separator. This already exists. I don't need to write this. Sorry. Excuse me. I don't know why that's there. Let's get rid of that. Excuse me. My goodness. Okay, so if we have a response string, we can just split it with commas and then do what? I assume we just, yeah. So let Earl's string dot split, comma, response string in model, model status equals I guess we need to like pattern match. Okay, this is interesting. Loaded. Yes. I see what's going on here. All right, so this is basically what we're gonna do. Something like this. All right, so photos are going to be list map and then this shouldn't work because this is a maybe. I assume that is just going to be like, you need to update this. Yeah, and there it is. Oh, interesting. I've not seen this yet, but yeah, this is kind of cool. All right, check this out. So we're going to rewrite this a little bit. Case string split, comma, response string of. All right, so here we're going to say if you have first URL and anything else as URLs. I've not seen this before. This is kind of cool. Then we can say let photos equal list map Earl Earls in Uh, loaded photos first URL. So I'll explain why this is cool in a second. All right, and then here, I think we just say errored. Something like this. Yeah, so this is new. So this is something I have not seen before. Yeah, I'll let you talk to him about that. Okay, so this in Haskell looks like the following. So it's like X, well, I'll say URLs at first URL like the following. And really, yeah. So this is like pattern match out the first one and some other list, and then keep the whole result in URLs. So you can do this in Haskell as well. So Haskell equivalent. So if anyone is coming from a Haskell background, which I am, that's what that looks like. So I didn't explain this at the beginning, but you know, I'm thinking of this web programming language from the Haskell background, not from a JavaScript background. So if you are from, I don't have a project, Aman. I do have this right now. So this is Elm in action. I probably should have a project. That's not a bad idea. Maybe I did at one point, but it was annoying to switch back and forth. But like right now, it's just Elm in action. Also, hi. I think it's been a while. I would agree with that, and I think it's a lot of it is because Elm is much simpler, right? In sort of model or modern Haskell, there's a lot of stuff going on and a lot of symbols that don't make any sense. You don't really get that here. There's not a ton of symbols that make it difficult, and there's not a ton of syntax either. So I think it is helpful. Okay. So I think now we should compile, but I don't know if it will show anything. Let's see. So we've compiled. I wrote this little script just to basically keep an eye on my main, and if it changes to just recompile, so we don't have to like. It's still not showing anything, so I got to figure out what that's about. Probably because we'll see here in a second. This is cool. I like this a lot. Excuse me. Yeah, so Aman, somebody said that very similar thing to me on Twitter. Is like Elm is great to get you started, and then eventually you'll feel like it's not powerful enough and switch to PureScript. So we'll see if that happens to us. Most of what I'm doing is very basic, and so I kind of like the simplicity of Elm. And it seems like people are doing pretty good stuff here. So I don't exactly know what PureScript gives you that Elm doesn't. But again, you don't have to explain that to me if you know. It's just something that we'll definitely explore in the future. Okay. Oh, right. We still haven't even, we've never triggered got photos, so we still need to do that at some point. Oh, I see. Okay, it's trying to make a point that this is just our photo constructor. That's a good point. Yeah. Oh, no, that's totally fine. I've heard that before. So here's the problem with Elm Reactor is that I have an index.html. So here, I don't want to do it here. Let's do it here. So if you look at my structure, I have this index HTML, which loads some styles and stuff. So I don't know how to deal with this kind of stuff yet. So it like loads some styles, includes our JavaScript, and then uses this, the Elm entry point. I'm not sure exactly what to call that. So if I use Elm Reactor, and, or do I just do this? Oh, I can do that. Oh. Well, let's see if this works. I didn't think about doing that. So what I did before was do this, but it shows, you know, it doesn't show my CSS. Just for reference, there should be nothing here right now. We're not done yet, so just keep that in mind. I did not think about just pressing this, but I don't know if it will build everything behind the scenes, so I guess we'll find out. I mean, the easiest thing we can do is... What? Why don't... Oh, right. I want to see if it shows something and automatically compiles, basically. So text hello world. Does this compile? Oh, well, not doing anything. Will Elm Reactor build this for me or no? Yeah. I mean, I guess. So, yeah, it's like just, you know, the Elm stuff. So I think, yeah, so I think I actually do need to do it with the Elmid. So, oh, yeah, so, oh, it's supposed to exit. All that is like a stupid script that I wrote. It's like not interesting at all. Yeah, so you can see how this kind of works is if we did that and then we did hello, we can write world, save it, and then refresh, and it will just be there. So that's kind of what we're using that for. It's not a fancy solution at all, but it would be nice if Elm make had a watch feature. And then that way over here, we could just do Elm make instead of doing it in a loop over and over again. Or Elm make watch instead of this. So we might have to like implement that at some point ourselves. Okay, so I was thinking about that. I actually submitted a PR to add some short options to Elm format. So maybe I can try and figure out how to add the watch functionality to this so that you can have, you know, a similar thing to GHCID in Elm. That's kind of the idea anyway. It would be pretty useful. Depends how hard it is to make. Okay, anyway. So it says there's one more refactor we're gonna make. What's this complaining about? I thought we did use it. All right, so we have a case. Wait, what? We have this case inside of a case. Inside of a case. You can see it's getting a little unruly. Oh, okay, I see. So what they're saying is like maybe it makes more sense to do the following. All right, so this is functionally the same, but you know, we're doing some more explicit pattern matching instead of casing. So I don't know what's better. I don't know what the Elm community prefers, but I think this is pretty readable either way. It just ends up being a lot of nesting, right? Like being able to remove that nesting makes it a little easier to read. Do. All right, so it says about local JS run. That could be as well. I have no idea. That's an interesting point though. Yeah, maybe I need to like allow that in the browser. I didn't even think about that. But this is working for me, so I'm not too concerned about it. We removed that, so it went away, not surprisingly. All right, so now we need to go. No, initial model. So basically, I think what we want to have happen is we want to trigger a command quickly. That's kind of the idea. So we're going to do http.get URL equals I don't want you snooping on my traffic. Expect string result photos result. Okay, just unused. Okay, so something weird about this that I agree with is the type here is message, but the type for expect string, we can. Well, actually, wait a second. I just want to make sure it's not going to print my IP address or anything. That's what I'm just making sure of. I don't think it does, but mm, one second. We're almost done. Yeah, it seems to show up. So it, yeah, so I think you're right. It has to do with the JavaScript. Interesting. Well, that's I think we aren't we there? We must be there because the color is there, right? I don't think we have to. I think it does it automatically. Actually, you can see the get for /elm.js. So this should work as well, but you have to start an HTTP server. But this is working, so yeah. But you were right. And also notice like some things you get the actual Elm symbol as the what is this thing called? Favicon? Not sure how to pronounce it, but you know, you do get some extra stuff there. So actually maybe it makes more sense for us to start this way. I don't really know. I mean, this is working, but maybe when we do something more complicated, it won't matter. But it will matter. So I'm gonna keep this in mind, though. That's an interesting point that I didn't really think about. So thank you for that. Actually, I need to write that down somewhere. We still need our watcher, right? Because we still need to build Elm.js, but that will, you know, maybe there's also like one of those that does live update, and then that way all we have to do is go and look, and we don't have to go back and forth. That would be an interesting idea. It just like updates every whatever seconds, something like that. Okay. Okay. So actually, it's do I have any jobs? No. It's not as interesting as I thought. So basically, got photos is a message, right? We've called it type message. So that's the return type. So it's fine. You don't have to be specific. It's sort of interesting that this takes a record. See? I kind of wasn't expecting this. It takes a record as input, but that's perfectly acceptable. That's what those type aliases were or are that we were talking about before. So perfectly acceptable to do. It's just I haven't seen it yet. So. And then all this get is doing is making sure that we get this result and then creating the message. So I would have actually guessed that this should start showing pictures, shouldn't it? Maybe our view function's not actually complete yet. We'll see. Oh, we haven't triggered it. That should trigger it. Okay, well, we got a server error. So we got something. Okay. Well, we didn't get any pictures. We got a server error. Oh, you know what? I bet you. Yeah. It just doesn't speak HTTPS. So, it is what it is. So we got an additional photo here of, I guess, a guy walking downstairs. Honestly, I don't know what's going on in that picture. This one's more obvious. You know, concert, forest. I don't know what this is. Our surprise me still works, although we haven't. Okay, we got that once, and our thumbnail thing works. So cool. We did an HTTP request. All right, so now I think what we're gonna do is switch to a JSON import. Probably that would be my guess, because that's the next thing on the list. So Elm install Elm JSON. Okay. Yes, we would like it as a direct dependency. All right, so it says plenty of things can go wrong during the process of decoding JSON. Suppose the server messes up and sends us XML instead of JSON. Or suppose we get back a response that's valid JSON, but a required field is missing. So what we do is return a result, which again is like an either type in Haskell with error and a value. So we're going to try and decode a value. Or we're going to build a decoder, I guess, and try and decode a value. Anyway. Da, 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 da. Okay, so let's try this in Elm REPL. We can import JSON decode, exposing everything, and then we can write decode. Is this not autocomplete, or have I not noticed that before? Bool true. Okay, so you can see that the result is either an error or a Boolean, and we got an okay true. So it means things went okay. But if we put a 42 in here, we would get an error expecting a bool. And one thing to note is the first, I don't know what internals mean here, but it looks like the first thing is the string. So we might be able to just print that out. Okay, so we can try decode string. Okay, that works. So I assume that this does not work, or does it work? Yeah. So your right, a JSON string has to be escaped, so, or it has to have quotes around it. So the primitive decoders that are available: bool, int, float, string, and null. All right, so if we want to decode JSON arrays into lists, I presume that we just say something like decode string maybe we can write this. I have no idea. We may have to use some sort of like a builder to say, look, it's a list, and then true, false, true. No, that doesn't work. We need, well, we can just look it up. But it's the list function. There you go. So again, we could have looked that up, but it tells us here, so. All right, so it says the simplest way to decode an object is the field function. Suppose we write this. I'm not gonna write what they write. I'll just write something on the command line. So we can say like field email, well, is there bool. Then we can probably do is there colon true. Think this is valid, JSON? Yep. So, right, we have a key is there and a value of true. So we can say grab the field is there, and that should be a Boolean. Okay. Says when this decoder runs, it performs 3 checks. Are we decoding an object? Does the object have a field called is there? Is the object's is there field a bool, basically? Now, decoding multiple fields. Building a decoder for a single field is all well and good, but typically when decoding objects, we care about more than one of their fields. How do we deal with that? The simplest is with a function like map2. So this gets an A and a B and produces a value. Okay. So we can say map2 int, and then we want to say decode string this whole thing, and then oh, you know what, this is probably, can you see this? You can, but it's soon going to be not visible. So let me do the following. So we'll say f equals this, right? That's our decoder for 2 integers, basically. But that's as a tuple, which is kind of weird, right? Like it's decoder int, but it actually operates on the following code. So if we write decode string f, and then we need to generate the JSON for this. So x1 I swore. So when we swear, we put into the swear jar. And if we put in a swear, eventually the swear jar is basically going to be a gifted sub, by the way. So I'll just gift a sub to somebody. Okay, so that worked. It just returns them back as a tuple. That's the idea. Okay, so the type that we had here is like how they're returned. That's interesting. So can we put them in a list? They're both integers, so we can. Now, is it smart enough to realize that if this was a float, this shouldn't work? Nice. Beautiful. So these are the kind of things that are pretty cool. Like if I want to do a float, the only option I could do is with a tuple, right? Because I have to mismatch these two types. So then I could do, 2.2 and it should be fine. So that's kind of nice. Compiler protecting you against, bad code. All right, so it says the photo information we're going to be getting back from the server looks like this. Okay, so basically what we want to do is we're going to have a URL that's a string, a size that's an integer, and a title that's a string as well. So now we're going to use new fields. So let's close this. And do I still have that there? I do. So foreground, photo. So now we're going to have a URL of a string, a size that's an int, and a title that's a string. And we're going to go through and start fixing that basically. So here we need to build a decoder. So photo decoder photo. No, that's an alias, so I can't do that. So it will be like UST photo and then we need a string decoder. So, oh, right. Field URL string field size string field title string. Wonder how many map functions you get. Oh, and then we also need to import JSON probably. How did we do it on the command line? Ah, I shouldn't have closed that. Okay. Oh. Thank you, compiler. What's wrong with this? Oh, this is just something else. Why is this complaining though? This shouldn't complain. Right, type alias. I'm confusing these things again. Okay. All right, what's the next thing to fail? Oh, there's apparently a better way to do this. So Elm install no red ink Elm JSON decode line. And then I assume, oh, I see. So we're gonna get decoder int list string succeed decode pipeline optional required. Okay, so from here we're gonna say succeed Does anyone know what this looks like? No one? Can't write that? I have to write the whole thing? That's unfortunate. So what could it mean? No, it's in attributes. That's unfortunate. So how do I qualify import? I don't remember. Elm qualified import. Thank you. Sorry. So let's just call this as pipeline. And then that way we can just write pipeline. Which previous question? Oh, apparently we can't do it this way though, but that's fine. Can we do it this way? Or no? Nice. Oh, the question was, what does this look like? Does this remind you of anything from Haskell, basically? Because it reminds me a lot of something. It might not be like wildly obvious, but it's applicative, exactly. You know. We'll leave that there. It's exactly applicative. Yeah, so we got this nice applicative setup. I don't feel the need to separate out this yet, but maybe we will. Maybe it will make sense to separate that out as another function. Yeah, so there's a lot of explanation here about like what's going on, but we know what applicative is, so we don't really have that kind of problem. I'm not too concerned about how the details of this. Okay. So we've already seen how to use HTTP expect string to obtain a string from the server, and how we can use decode string and a decoder to translate. Although we could use expect string and decode string to populate our model in this way, there is another function in the HTTP module which will take care of both for us. Expect JSON takes a result to message and a decoder and gives you back a expect message. Where's bad body? See where that's messaged or mentioned, excuse me. Okay. So we're gonna go to initial command. And instead of grabbing list, we're gonna grab list JSON. Then we're going to expect JSON. And we're gonna say got photos. List photo decoder. So apparently we're gonna have a list. This comes from JSON decode. Oh, we're gonna have to fix our message, right? There. Okay. So we no longer have this. We're basically just gonna have something or nothing. And we no longer have this map thing. I see. So like that. What is this complaining about? Right. I just saw operator. Do I need to physically write something there? Oh, right, because this has to be a case. I'm stupid, sorry. Right, this first is actually a photo, and this is unnecessary. So I was actually pretty close, it's just, I wasn't messing with the right types. There we go. All right, so then what we want to do is add that metadata. So we use this thumb URL here. And what we want to do is add a title. So we're adding its thumbnail size. Oh, I'm missing a parenthesis. Is this parenthesis? There you go. So now we're getting more. And where's the title though? Oh, okay, it's like a it's not. Oh, this is okay. Yeah, this is part of its parameters, or it's like metadata. Yeah. So apparently there must be like a hover or something in the CSS, which is on the web server, so I'm not going to try and get it. But there must be something that allows you to do that. So this one's untitled, but it still has a size. Boating glass, untitled. What's this one called? City Museum. Beachside. Epica. Is Epica? That. Yeah, the Dutch metal band. Thought I've heard them before. I don't remember exactly what they sound like, but anyway, here we go. All right, so what did we learn about while we were doing this? We learned about decoders that can validate and translate JSON. We learned about the applicative style pipeline decoder, which is really nice. The JSON decode module includes things like float, int, string. We can also decode bools and lists. Explicit pattern matching. So instead of where was it? Okay. So instead of something like casing on this result, you can actually just like pull that out. So like we could even take this a step further if you wanted to and do something like the following. I suppose. Can we do this? Is this allowed? Right, so if we don't want all those case messages, we can do stuff like this. So you could also, you know, I don't know if that's more readable, but that's an option. This kind of starts, you can see how this can get like a little hairy, but you know, not that bad. You know, we could do a very similar thing here if we wanted to, especially because these things, you know, these things are repeated. So actually I kind of like doing that here. We could do the following. Let's just do this. So we could write click surprise of loaded first other and then these ones are, you know, doing nothing. So you can see how this, what's this complaining about? Oh. Oh, okay. Oh, that's a pattern match. Okay, never mind. We can't do that. The only way you could remove this duplication, I suppose, is by putting in the status to click surprise. Or, I mean, the rest of it is trivial here. You can just do... This is fine, too. If you don't want it. If you don't want that duplication. Unfortunate. But it doesn't really make sense to sort of status inside this click. yeah, this can be simplified as well. Can I do multiple? Like, can I explicitly pattern match on this here? Apparently you cannot. Because it says no signature for select URL. That's totally fine. It just, you know, I do like that about Haskell. What else can we simplify? Anything offhand? I don't know how to simplify this right now, so. So this is pretty good. Like, we should clearly just do this for now until it doesn't work. Like, that was the only ambiguity, so. Not using this anymore. Actually, are we using array at all? I don't even know. I don't think we are. I think we can just remove that. Yep. Okay. Let's see, what else is in here? We learned about the pipe operators. We sort of knew about the pipe operators, but I didn't think about using it there. So it's just like a nice reminder to use it. We learned about the result type, which gives you an OK for good values and an error for error values. We learned about string split, although I don't think that that's particularly useful when we're talking about like HTTP requests. We learned about get. We learned about expect string, expect JSON. Decoders I already mentioned. We learned about the init field, so you can actually pass, like if you need to load data, what's going on? You need to load data on startup, you can init with a command instead of just none. So like if you don't require any, state to get you started, then you can just you can just start working on your code. Okay, so that is it for the day.